Hi there and welcome back. In this video we're going to discuss the physical properties of the high pressure fuel pump. As can be seen in this picture, the top of the fuel pump has a device called a damper. I prefer to call it an accumulator. It accumulates excess fuel more than the pump needs at any given time. And this is fed from the in-tank low pressure fuel pump. The low pressure fuel pump normally runs around 70 psi, which is 4 bars. But it can go up to 7 bars. For example, if your system ends up in limp mode and the high pressure fuel pump's not working, then the in-tank fuel pressure builds up to 7 bars and the engine will run with less power. So the low pressure fuel, demonstrated by the green arrow, is compressed by the piston moving up and down, represented by the yellow arrows. And the high pressure output is represented by the red arrows. So now let's look closely at the control, which is the center portion of this fuel pump. Notice that this image has the high pressure outlet on the right hand side, but it shows much more detail about how we control this pressure. On the left hand side of this drawing, it shows that the coil is energized, which pulls the control valve plate to the left and closes and allows the piston to develop pressure. Now it just so happens that once the piston starts moving up with this control valve plate closed, then the solenoid can shut off because the pressure from the pump will hold it closed. This saves energy, it saves current draw on the engine control computer, and that's what they do. Once the thing is successfully closed and pressure is rising, then they just turn the solenoid off. When the pump piston reaches the top and starts to go down, then that reduces the pressure on the right side of this control valve plate, and the plate opens up and allows the piston to draw fuel in from the damper or accumulator to fill the void as the piston travels down. While the solenoid is in the off state, the solenoid spring holds the control valve plate in the middle of its chamber such that fuel can flow both directions around this control valve plate. So now the pump output pressure is feeding the outlet check valve is now the electric fuel pump pressure, which is 70 psi. And notice this outlet check valve won't let the fuel rail pressure come back into the pump. So there's excessive fuel rail pressure right now compared to what the pump is putting out. I think that's why one of the reasons they fire that 200 microsecond GDI injector all the time is to keep carbon from building up and also to rebalance this fuel pump output. One thing you may have noticed is that in all these drawings, the pressure relief valve is shown wrong. It has to dump back to the accumulator. It can't dump back to the fuel rail. So that's kind of silly, but they're all like that. The Theta 3 high pressure fuel pump during idle is not zero fuel pressure like it says here. It's the 70 psi from the in-tank fuel pump. And as long as the valve is open, because the solenoid is de-energized, then the fuel rail only sees the 70 psi. Here you can see the solenoid energized part way up the fuel pump compression stroke, which will cause pressure higher than 70 psi. Because it's compressing the later portion of that stroke. Here we can see the pump producing maximum pressure because the solenoid is energized before the piston starts compressing. So there you have it. This is how the HPFP fuel pump works mechanically.